Good morning, everybody.
Good morning, teacher.
Hi, Rose. So last time we were working with how to solve some specific type of system of differential equations. And that type is the kind called homogeneous system of differential equations. By homogeneous meaning that the forcing function involved in the system of equation is a vector of zeros. So we can see here in the screen a homogeneous system of equations. So you can see that there is no independent terms. All of the terms involves y1, y2, or one of its derivatives. So we have two equations. We will get a system being, or a system of two equations with two unknowns. In this case, the unknown functions are y1 and y2, but they can be called anyway. So how do we solve a system of equation this kind? Well, first of all, we need to write the given system into a matrix form. So we have something like following. Something called the matrix equation. And here you can see this is the matrix equation where y prime, capital Y prime, is a vector, or in this case, A is a matrix and Y is another vector. Vector formed by the variables. So you can see here, Y is expressed in this way. We have two values in this matrix, Y1 and Y2. And here we have Y prime is another vector, column vector matrix, having Y1 prime and Y2 prime, the derivatives of our variables. And we have over here the so-called coefficient matrix. A, in this case, is the coefficient matrix. And the coefficient, and getting the coefficient matrix is one of the first steps in solving this style of system. And the coefficient matrix is easily get directly from the system of equations once the equations are ordered according to the variables. That meaning on the left side you will have the derivatives, and on the right side you will order however you want, but you need to order the equations. In this case, we have the y1 term first and then the y2 term in both of the equations. As you can see, in the first case we have negative 4y1, and in the second one 6 times y1. So first we have the y1 term, and then we have the y2 term. That is order. So once you have order your equations, you can easily get the coefficients. For example, negative 4, negative 3 will be the first row. Here is the first row. Positive 6 and positive 5 will be the second row. And then you have your coefficient matrix. So once you have the coefficient matrix, you need to write an important matrix, the matrix A minus lambda I. You will use this matrix A minus lambda I to get two important things. First, the eigenvalues, and from the eigenvalues you will get the eigenvectors. And why are they so important? Because the solution for this type of system of equations involves using the eigenvalues and the eigenvectors. So once we have the matrix A minus lambda I, we will find the determinant and we'll make that determinant equal to 0. From there, we will get the characteristic equation. And the roots for the characteristic equation are called the eigenvalues. So here is the matrix A minus lambda I over here in terms of a generic lambda. And we'll write determinant for A minus lambda I. Here it is. And you know that the determinant for a given 2 by 2 matrix can be obtained doing the cross products and subtracting such a cross products. And here is shown that calculus. And from there, we're going to get a second order polynomial, and we're going to make that polynomial equal to 0. And this is called the characteristic equation. The determinant of the matrix A minus lambda I equal to 0 is the characteristic equation. So you find the solution, the two solutions for this characteristic equation using any method you like, and you will get the roots of that characteristic equation, and they will be called the eigenvalues. The eigenvalues and the eigenvectors are studied in the linear algebra course. So here we're just taking an overview of such concepts, and moreover, we're just going to use the concept of eigenvalues and eigenvectors to get the solution to our system of equations. So once we have our eigenvalues, now we're going to use once again the matrix A minus lambda I. Remember that in this case, A minus lambda I is a 2 by 2 matrix, and lambda I is another 2 by 2 matrix, and that's the condition in order to the subtraction to be valid. And for the product, we have a 2 by 2 matrix, so the eigenvector has to be a 2 by 1 matrix. So the number of rows, number of columns of the first and the second matrix are the same, 2 in this case, and the resulting matrix will be 2 by 1. That's another column matrix. So we establish this equation. The product of the matrix A minus lambda I times the eigenvector will be equal to 0. And we're going to use such an equation to find two eigenvectors. How are we going to do that? We're just simply going to replace this lambda using our two eigenvalues over here. So we use lambda 1 equal to 2, and then we use lambda 2 equal to -1, replace respectively in this equation, and solve for eta. We need to solve for eta. Eta is the eigenvector. So when we use lambda 1, we'll have eta 1, and then we're going to use lambda 2, and we'll get eta 2. That's two eigenvectors. So how do we solve this equation? Well, we replace lambda 1, in this case is number 2. We use our coefficient matrix, A minus, this is lambda I, and we just do the subtraction, and here is A minus lambda I. So here we have, this is the resulting matrix A minus lambda I times our vector our eigenvector, which has two components. Let's call those two components A and B. You can call it any way you want. It doesn't really matter. In some books, they are called eta 1 and eta 2, these values. But it doesn't matter. So with this product, you will get a system of two equations. So here is the resulting two equations. Usually, one equation will be a multiple of the other equation. Whenever you have a system, two equations, where one of them is a multiple of the other one, then you only have one equation. Because having a multiple of another equation means you will have an infinite number of equations. It means you are dealing with the same line. In this case, remember, a first order equation represents a line, graphically a line. So you are dealing with two parallel lines. So two parallel lines never cross. So you have an infinite number of solutions. So that's why you can solve this system of two equations. The best you can do is write one variable in terms of the other one. Because if you try to use any method, you will find that they're going to cancel. For example, in this case, if you multiply the second equation by -1, you will get exactly the first equation. If you add them, then all of the left side will be canceled and 0 will be equal to 0. That's true, but it won't help you to find the solution. So you better use one equation and solve for one of the variables. For example, this is one solution, b equal to -2a. How much is a? You don't know it. Or you can solve for a equal to -1/2 times b. And what's the value of b? We don't know it. So we can use any value for b. We can say b equal to 1, then a will be equal to -1/2. If b is equal to 1, then a will be equal to -1/2. Or you can use the first. If a, you give a value, any value for a, for example, 1. If a is equal to 1, then b will be equal to -2. So this is a pair of solutions for this system of two equations. So which pair do you use? Anyone. Anyone. It doesn't matter. You just need to use a solution for this system of equation. And you will see that these two solutions are a multiple of each other. For example, in this case, we have used a equal to 1 and b equal to -2. But we can use b equal to 1 and a equal to -2. And as you can see, this is a multiple of the first term. If we take this term and divide it by -2, so if I multiply this eigenvector by -1/2, we will get the first. This is the first eigenvector. Then we will get something like this. It's not equal. Then we will get this second eigenvector, which is simply another solution. B equals 1 and a equals -1/2, which is this solution. So you can use any value. You will end having a multiple of an eigenvector. And what if you use just a multiple? There's no problem because we're solving this equation. Having a multiple for this eigenvector is having a number over here, k times eta 1. And if we move this k to the right side, we will have 0 divided by k, which will be equal to 0. So you can use any number here, and the solution still will be the same, because you can always move this number to the right side, and it will be divided into 0, which will be equal to 0. That's why you can use any one of these solutions, because they will always be a multiple, and that equals a k factor being multiplied. So it doesn't matter. You can use your eigenvector or a multiple of your eigenvector. In a similar fashion, we solve now for the second eigenvector using lambda 2 now to form the matrix A minus lambda 2I. And once we have that matrix, we establish our equation. A minus lambda 2I times our eigenvector equal to 0, and we solve. We find the solution. Once again, here we have the expression b equals to negative a, or a equal to negative b, whatever you want. You use a value for a and you find a value for b, or you use a value for b and find a value for a. It doesn't matter. The important thing is having an eigenvector from that satisfies this equation. So we now have all of the needed components. We have our two eigenvalues, our two eigenvectors, and with that, we simply use the formula established to write the solution to this kind of system of equation, homogeneous first order system, linear system of equations. And that solution is y, this is a vector. The solution vector, y, will be a constant, C1, times the first eigenvector times e to the lambda 1t plus C2 times the second eigenvector times e to the lambda 2t. And this is very similar to the solution given for a single homogeneous linear first order equation. Of course, because you still have two of that equation, of those equations. And so the solution is written in a similar fashion, but this time we are using the eigenvectors and the eigenvalues. And we just replace our eigenvectors. In this case, the eigenvector 1 is 1 and negative 2, and the eigenvector 2 is 1 and negative 1, and we use lambda 1 and lambda 2, our eigenvalues, and then here we have our solution. That this is the matrix form, of course, and can be written as two simple equations, and that is the solution. So this is the whole method explained, and we have worked out with this example on our last lecture. So do you have any question?
No, teacher.
Thank you, Anna. So if you don't have any question, We're going to work with the Kahoot. So please open Kahoot on your devices. You can use your phone or you can use your computer. And with this Kahoot, I just want to check that you have full understanding of the process used to solve this type of system of equations. Once again, it will be a step-by-step process. You'll please write down your
Sorry.
ID number, student number. Yep. Okay, I have 22 of you on the list, but I have just 18 players. Okay, thank you. So you're ready. Or I'm still missing one of you. Who's the one? Is anyone having problems logging into Kahoot? Please tell me if you're having problems, because you're not going to be able to take this quiz later.
Creo que yo, profe, no,
Hmm?
no aparezco en la pantalla, pero según yo ya me metí.
But you're not counting. We have 21 and you are 22, Adrian. And what is your ID number?
A0173-387. Ya, pues.
Yeah, so you are not the one. I'm still missing one of you. Okay, I will verify it anyway, so don't worry. I will know who is not presenting the quiz, and you will not be able to present it later, okay? I'm so sorry. So let's work with that. So you're given a system of two equations. You are asked to find the matrix form. So basically, you need to find the coefficient matrix. Okay, well done. Very good job. In this case, we have an IVP that implies another vector. In this case, the vector called x0 or x of 0, and it is 0 and minus 4. So in this case, you just have to say if it is true or false that if you have A, the coefficient matrix, you need to find the matrix A minus lambda I, find the determinant. So you just have to say if it's true or it is false that this is the determinant. it is false. So, having the right characteristic equation is a -4 instead of -3. If we make that equal to 0, we have the characteristic equation. So we just need to find the eigenvalue. Two eigenvalues. Okay, very good. Now, once we have the eigenvalues, we can find the eigenvectors. So let's find the eigenvalue, the eigenvector corresponding to lambda equal to -1. So remember, you need the matrix A minus lambda 1. Oops. And coefficient matrix. Forgot to place figure of the coefficient matrix. So maybe you don't have the coefficient matrix, so you won't be able to find the results, but if you did, please give your answer.
Profe, pero esta pregunta depende del supuesto que tú pongas inicialmente, ¿no?
Sorry?
Que esta pregunta, la respuesta va a variar porque depende del supuesto que cada quien haga.
It's the same coefficient matrix. Didn't you write the previous coefficient matrix? It's the same, you use that.
No entiendo.
In the previous exercises, we have been using a coefficient matrix. It's exactly the same coefficient matrix.
No, but the guess for A or B.
Oh, yeah. But you can try to check if your guess corresponds to one of these or it is a multiple. It's easy to find a multiple. Okay, a lot of problems here. So let's suppose that you get your eigenvectors -4 and 0. So you can say, there is no, my answer is not in your 4 options, but you have -4 and 0. So what about the option -1 and 0? It's a multiple of your solution, -4 and 0. You just have to divide your solution by 4, and you will get -1 and 0. It's easily to find. Remember, you will find a multiple. So the right answer is -1 and 1. But maybe you find, I have -2 and 2. Obviously, the right answer is -1 and 1 because it's multiple of -2 and 2. In a similar fashion, you could have -1/2 and 1/2, and it's a multiple of -1 and 1. So that's how you determine which one is the right answer in this case, because whatever you have, it will be a multiple of one of these vectors. Is that clear?
Yes, teacher.
Thank
Yes.
you.
Yes.
Now, I'm really worried because only 7 of you were able to get the right answer. So I would like to hear what happened. I have 8 with the blue answer. What happened? Why did you answer 1 and 1 instead of -1 and 1?
Yo le piqué mal, profe.
Okay, thank you. One list. And what about the other 7 blue answers?
Yo no leí que decía que era con el -1. Yo lo estaba haciendo con el 4.
Okay, thank you. What about the other 6?
Yo creo que hice mal una multiplicación porque me salió un signo, o sea, me salió menos. O sea, la ecuación sería A menos B, me salió. Por eso pensé que era 1 y 1. Supongo que
Okay, and what about your 5? Oh, no vi que la roja tenía -1. Okay.
Sí, también me pasó lo mismo, profe.
4. We have 3 now. What about the other 3? The other 3 blue answers.
A mí nada más se me acabó el tiempo, profe.
Okay, thank you. What about the other 2?
Profe, lo mismo pasa con los signos, ¿no? O sea, checas que los signos sean como intercambiables.
Interchangeables.
O sea, que equivalgan, pues, o sea.
Yes, of course.
Okay.
Yeah, maybe you can have an answer that is a multiple of -1, for example. You can have an answer as 1 and -1.
Mm-hmm.
And 1 and -1 will be a correct answer.
Okay.
Because it is a multiple of this vector. You can multiply it by -1 and you will get that.
Okay.
Okay, and what about the 3 red answers? What happened? Is anything that is not clear enough for you? Please, those of you who answer with the red option.
Yo me confundí cuando cambié de pantalla, entonces le piqué a la equivocada.
Okay, thank you. It was just a mistake. Thank you, Jorge Quiroz. Okay, and what about the 3 who chose the green option? Please tell me what happened.
Yo traté la ecuación como un escalar. O sea, de multiplicarlo por un escalar.
Okay,
Sí.
thank you. Okay, well, it is a vector. What about the two other greens? There's no answer for the two other greens. So you just don't want to talk. That's it. You need to know that there is no problem making mistakes in life. There's no problem at all. That's the way we learn. That's the way in how we success in life. So there is no what to be ashamed of. We need to try and try and try until we success. That's the way for success. So please, there's no problem if you make a mistake right here. The big problem is when you don't care about learning from that mistake. That's a big problem. That's a problem. So please, if you have makes a mistake, you just simply say, oh, I had this problem. I thought this was the solution because of this or because of that, etc. But you need to ask. You just don't shut up and don't say anything. That's a big mistake. Don't do that. Okay, so next question. Now we're going to use the eigenvalue lambda equal 4 using the same coefficient matrix. Okay, similar result once again. Okay, what about the blue answer, the 7 blue answers? Tell me your story. What happened?
Yo todavía no la acababa de resolver. Estaba en eso.
Okay, it's just a matter of time. What about the other 6?
Yo creo que lo tomé como un -4.
Okay. Thank you.
Se me fue un signo, profe.
Yeah, this the
Sign.
signs.
It's a sign, okay.
Yeah, because I had 2 equations, and with one equation, I had the right answer, the one in yellow, and with the other equation, I had the green one.
Okay, you had a problem with the sign, maybe, right?
Yes.
Please double check your results. That's quite important.
Profe, yo
Pues,
tengo una duda. ¿No es lo mismo la verde que la roja?
Yeah, you're right. They are the same answer. Because the red one is a multiple of the green one. You just multiply the green one by -1 and you get the red one. So the red answer is correct. So I will correct it. And please, if you can send me a message to remind, I will correct this one. Okay, so we now have the 2 eigenvalues. Let's work with the eigenvectors. And it will be just one final question. So we have the following as a solution for a system of equations. With the given initial conditions, the right equations to find the constants are, so you have the solution, is matrix equation, and you have the initial conditions. So you need to replace initial conditions for time equal to 0. So you need to replace t with a 0 in your matrix equation, and your equation will be equal to the vector 0 and -4. So what is the resulting system of equations in order to find the 2 constants? place for 48, the second place, and the winner. Congratulations. So I'm going to name all of you one last time. Jose Francisco Zavala, are you there? Emilio Olvera.
Here.
Frida Paola.
Here.
Luis Alberto Díaz. Ana Karen Priego.
Here, teacher.
Roberto López. Rogelio Neri.
Roberto aquí, profe.
Rogelio Neri.
Here, teacher.
Thank you. Luis Fernando Luébano. Isaac López.
Here.
Ulises
Profe,
Pérez.
aquí estoy yo, se me trabó el micrófono.
Ok. Ulises Pérez. Salvador López.
Sí, profe.
Jorge Alberto Quiroz.
Here, profe.
Eric Viveros.
Sí, estoy aquí.
Profe.
Who's one? Eric
Ulises.
Viveros. Ulises. Eric Viveros.
Aquí.
Adrián Castro.
Okay.
Iser Caleb.
Aquí, profe.
Sergio David.
Aquí, profe.
Eros Apolo.
Here, teacher.
Hugo Enrique.
Here, teacher.
Francisco Rubio.
Aquí, profe.
José Alfredo de Guadalupe.
Here, teacher.
Sandra Cortés.
Aquí, profe.
Ariadna Julisa.
Presente. Here.
Alan Alberto.
Presente, profe.
Y Montserrat Nava.
Aquí.
Two once again. So let's solve one last example just to finish clearing all of the doubts about the process. And we have here an IVP. So we need to find the constants because we have given initial conditions. So first of all, we need to find the matrix A minus lambda I. We will use that matrix to find the eigenvalues in the eigenvector and the corresponding eigenvectors, of course. So we have 1 minus lambda over here, 4, and minus 2 minus lambda. And that's matrix A minus lambda I. So the determinant for this matrix will be, ouch, I did it wrong. Okay, that's correct. So I have negative 5 minus lambda times negative 2 minus lambda minus 4 times 1, which is 4. And then we have 5 times 2, which is 10. And then we have 5 times lambda plus 2 lambda. And then we have 7 lambda. And finally, we have lambda times 2. And wait, 7, no, lambda times lambda, right? And there it is. That's our and minus 4. Okay. So we have lambda squared plus 7 lambda plus 6. That's the determinant. And we make the determinant equal to 0, and that will be our characteristic equation. Now we find the solutions for the characteristic equation, and we can factor this expression this time as two numbers whose product is 6 and whose addition is 7, and those numbers can be 6 and 1. This implies that the first eigenvalue is equal to negative 6, and the second one is equal to negative 1. These are our two eigenvalues. From here, we can use our matrix once again. I'm going to copy that matrix. So the A minus lambda I matrix multiplied by the eigenvector, and that will be equal to 0. This is the equation. So we replace our first eigenvalue, negative 6. So our equation will be negative 5 minus negative 6, which will be 6 minus 5 is 1. And for this term, we have negative 2 minus negative 6, which will be 6 minus 2, and that's equal to 4. And that will be equal to 0, right? Is that correct or not? So from here, we have the equation A plus B equal to 0, and this implies that A will be equal to negative B. We can use that. And if we use the value for A equal to 1, then B will be equal to negative 1, right? So our first eigenvector, let's call that eigenvector eta 1, will be 1 or negative 1. Or we could use negative 1, 1. It's the same. And now for the second eigenvalue, is negative 1. Replacing this value in this matrix equation, we have minus 5 minus negative 1 will be minus 5 plus 1, which is negative 4. We have a 1 over here. 1 over here, a 4 over here, and then we have minus or -2 minus -1, which will be -2 plus 1, that gives us -1. Times the eigenvector, and that will be equal to 0. And from here, we find the equation -4 times A plus B will be equal to 0. And from here, we see that -4A will be equal to -B. So B has to be equal to 4 times A. So if we use A equal to 1, then B will be equal to 4. And our second eigenvector will be 1 and 4. So we have our two eigenvalues over here. And our two eigenvectors. And from here we can write down our solution matrix form, which will be C1 times our first eigenvector times e to the lambda 1 t plus C2, our second eigenvector times e to the -t. And that gives us two equations. Y1 will be equal to C1 times 1 -1, okay, times 1 e to the -60 plus C2 times 1 times e to the -2 t, and then Y2 will be -1 times e to the -60 plus C2 times 4. So we have replaced over here the values for our first eigenvector of 1 and -1. And in a similar fashion, I have replaced over here the values for the second eigenvector, the values 1 and 4. So here is the 1 and 4.
Teacher,
Yep.
lambda 1 is positive, I think.
Lambda 1 is positive. Okay, let me check that.
Oh no, it's negative.
Lambda 1 is
Oh, it's negative. Sorry.
It's negative. Okay.
Thank you.
Anytime. So here are our two solutions. So let's replace now our initial conditions. Remember, our initial conditions is in the way of a matrix. We have a vector x of 0 equal to 1 and 2. And the vector, this is how we represent a vector. We can represent it this way, or we can represent it with a capital X. So using this notation, the vector depends on time, right? But for time equal to 0, for t equal to 0, the given vector is, oh, I forgot, 1 and 2. All the solutions are called X, nor Y. My mistake over here. So this has to be X instead of Y. We have X over here, we have X1 over here, and X2 over here. So this value over here is X1 evaluated on 0, and this one is X2 evaluated on 0. So here we have, if we replace X1 on 0, it is 1, that will be equal to C1 e to the negative 6 times t, but t is equal to 0, so we have e to the 0, which is equal to 1, plus C2, and X2 evaluated on 0 is equal to 2, so this will have to be equal to negative C1 plus 4C2. Okay, now we need to solve this system of equations in order to find the value for the constants. 4 times C2 and 1. Okay, now if we solve this equation, we say that we can see that from here we can solve for C2. C2 will be 1 minus C1, or moreover, we can just
eliminate C1.
Okay, we just add the two equations, and then we'll have 3 equal to 4 plus 1 equal to 5. C2, and then C2 will be equal to 3 over 5, right? 2 over 5. No, 3, 2 plus 1 is equal to 3. Okay, and then C1 will be equal to 1 minus C2, and from there, C1 will be equal to 1 minus 3 over 5, which will be 5 minus 3 equal to 2 over 5. Is that correct?
Yes, teacher.
Then our particular solution for this system of equations will be 2 over 5 times e to the negative 16 plus C2, which is 3 over 5 times e to the negative t, I think, yeah. And X2 will be once again negative 2 over 5 e to the negative 16 plus 4 times C2, which is 3 over 5, and that will be 12 over 5 e to the negative t. And this is our solution to the given IVP. And we are done. And thank you for being in this class. So we have two last challenge for the course. One of them is obviously the final exam, and the final exam is scheduled for this Friday. This Friday, is it Friday, June 3. (7 a.m.) and it will have a duration of 2 hours.
Teacher, this Friday is June the 5th.
Sería el miércoles, ¿no, profe?
Right. My mistake. I was.
No, it's June 5 at
Yeah,
8.
my mistake. My mistake. I was taking a look at July. June the 5. Okay, June 5, this Friday at 7 a.m. It will last 2 hours maximum. And
Profe, ¿no es 8:30 el examen?
sorry, it will be at 7 a.m. But did you have any problem with that time?
It's okay to me, teacher.
It's okay, teacher.
Okay, so 7 a.m. it will be. And the other challenge, it will be taken as our final project. And this will help you to make a review of the whole course, any of the different methods we have studied in this course will be in this batch of problems. So during this week, you will be solving about 20 to 25 exercises, and that will help you to make a review for your final exam.
Teacher, I have a question.
Yeah.
Those problems, you're gonna upload them, and at the end of the week, we're gonna upload the solutions?
Yes.
Okay, so...
In a couple of minutes, I will upload this batch of problems.
¿Y va a ser individual, profe?
Which one?
Lo de los problemas.
Los problemas.
Okay, both of these challenges is individual work.
Profe, ¿y vendrá nos va a mandar la respuesta, algo para el estilo, para saber si estamos bien o mal?
Okay, I can do that. Okay, I will upload the problems to Blackboard today, but the answers may be tomorrow or on Wednesday. Okay. I will upload the answers on Wednesday.
Okay, teacher, don't worry, that's okay. Teacher, I have another question.
Yes.
Do you remember the corrections that had to be done for last partial? For first partial grade? For the first partial grade?
Oh, yes.
Professor told me that the changes can only be done until tomorrow. I don't know if that's true. I just wanted to tell you in case you knew something about that.
Okay, but there's a problem. In case I cannot do any more corrections on the system, I will do it on Blackboard, and that's important one, because your final grade will come from the notes on Blackboard.
Ah, ok. Entonces cualquier cosa lo pondrás al final y ya.
Exactly.
Okay, that's fine, teacher.
But I will work on that today or tomorrow.
Okay, thank you.
That's no problem. Yeah. The exam will be on Blackboard, of course. And very important, I need you to have a camera. You need to turn your camera on for the exam. So what if you do not have a webcam, or your laptop doesn't have a camera, or the camera for your laptop isn't working? Well, you have the cell phone option. You can log in to the Zoom session both in your laptop or PC computer and your cell phone. So you don't have problems in turning your camera on. So please, every one of you need to have the camera on for the exam. Okay, any other question? Any other question?
Profesor, ¿podría subir el resto de las clases a Blackboard?
Yes, I can do that.
Gracias.
¿Cuántas preguntas van a hacer en el final?
The final exam will have about 6 or 7 questions.
Ok, gracias.
The final exam is designed by the Department of Mathematics. 4 of the professors given this course, differential equations, it will be designing the exam, but I think that's no problem. We have studied all of the themes for the course. So if there are no more questions, I will see you on Friday, and I hope you will have a successful final exam. I think now you're ready to tackle that exam.
Teacher, how worth is the exam?
How what?
How worth? Like how many points are there for the final exam?
Oh, no, I don't understand your question. What are you talking about?
Yeah, like from the whole course, how many points does the final exam count?
Okay, I don't remember that, but it's about 20%, I think.
Okay.
Is that right? Well, let me check it right now, please.
Profe, ya nos podemos retirar.
Yep. Yeah. We are done.
Nos vemos, profe.
See you guys.
Gracias, profe.
Goodbye, teacher.
Goodbye.
Bye.
Profe,
Yep.
tenemos dudas, ¿va a tener asesorías en la semana?
Okay, I hardly have, but yeah, send me a message, please.
Okay, thank you, teacher.
Okay. Okay. The final exam worth 30% of the final grade.
Okay, teacher, that's fine. Thank you very much. Have a nice day.
Same to you, Karen.
Profe, ¿y los parciales cuánto valen entonces?
%.
Sí, 50%. Está la nota en Blackboard, ¿no?
Yes, of course, that's right. That's
Sí, es que como en Blackboard también viene de un proyecto.
Ajá, lo que
And I have told you about your final project right now.
Ah, o sea, el pool de
You remember
preguntas
that
es el
I
proyecto.
told you. That will be taken as our final project.
Ah, sí, ok.
Perdón, no escuché bien.
I told you that.
Disculpe, profe.
That's it.
Disculpe.
That's it. I told you, we have 2 final challenge. And on Blackboard, you can find that there is a challenge with a 15%, right?
Okay.
That's a challenge. And that's the one challenge I told you. Okay?
Thank you, teacher.
Vale, profe, gracias.
Okay.
Nos vemos el viernes.
See you guys.